Welcome to Inventor Pro 2014 Puzzle Cube assemblies and part drawings. So we're going to take our part from part 1, bring it into an assembly, design a additional part, constrain them together, explode them, and then we'll create a couple of drawing sheets associated with that. So we've got a lot in store for you, so let's get started. In this particular case, what we're going to do is create a brand new assembly. And there's three different types of assemblies. There's one for mold design, one for welding and fastening, and then weldment base fastening, and then standard. We're going to use the standard assembly. Again, we're going to make sure we're in English since we're working in English dimensions. Standard assembly, and we'll choose create. What's different between parts and assemblies is that you get a different menu system. And the menu system up here at the top allows you to place parts from what is known as the content center. So like fasteners and springs, nuts and bolts, they're all in the content center. Great resource. We can also create a new component, which is what we're going to do to create our second part. But the other thing we can do is, instead of placing it from the content center, we can also place a part that we've already created. And so that's how we're going to bring in our first part, is that we've created the first blue part, part 1. We're going to bring that in, and then we're going to create part 2. So we're going to choose from the lower choice, because originally it was at content center. We're going to choose place, and when I choose place, it goes back to the last place I saved a part, which in this case was Puzzle Cube Part A. And so we're going to select our Puzzle Cube Part A and bring it in. We'll choose open. And what this does is this brings in our first part. Now we have to locate it somewhere in our drawing space, so we're going to go ahead and select it. The interesting thing though is that I can also create more than one. So if I need to bring in multiples of this, I can do that. Now we only need one of these pieces, but if I needed to assemble something and it had 5 of the exact same components, I just need to design it once, bring 5 of them into my assembly. To stop this particular process of bringing in extra parts, just right mouse click and choose OK or cancel. Now we've brought in our first part. Our second part we have to create. And so when we choose the create tool, it's going to ask us what is the part name. And it's going to be put in the same location of the part, the same location that the original part came from. So we'll say Puzzle Cube Part B. All right. It's going to be a standard part file. Now what's interesting is that I can actually make this a sub-assembly inside an assembly. So I can actually have parts and assemblies built within the same file. That's a little bit more complex. I'll probably be creating a new video on that here sometime soon. We're going to use the standard bill of materials, so we don't have any custom bill of material environments, and we'll choose OK. Now we get the little part icon attached to my pointer, and what it's asking is, well, what surface do we want to use as an XYZ location to work with? And typically we'll choose a surface on the existing part. And so I'll choose this. I can choose either the top surface or the side surface, depending upon how we're going to create the part. I'll choose the top surface here. So what it's doing is it just put a sketch, it just selected that as my common surface. It hasn't put a sketch on it yet. I need to put a sketch on this surface. It just said that that's the surface that the relationship is going to be based on. Choose 2D sketch, and notice where it's based. It's based on that surface, and I'm going to go ahead and choose the XY plane for it to work. So now we're looking at the XY surface. You'll notice that my part is slightly grayed or misted out, so that way I can see my original object, but I don't have to edit that particular object. You'll also notice in the browser window that it's grayed out. and that I'm currently working on a sketch. So part A is grayed out. I can make that my current part if I needed to, but we'll get back to that in a minute. But notice that it is grayed out. All right, I'm going to go ahead and draw again some shapes. So I'm going to start here at my starting location, and we'll kind of sketch this up here. Now I'm purposely going large on my part shape. Notice that the geometry constraint automatically popped up parallel there next to the other line. So it knows that those two lines are going to be parallel. Okay, so at this point I need to add my dimensions and my constraints like we did before. So we're going to go ahead and dimension this, make this a 1/2 inch. Use the equal tool, make this and this equal. And might as well make this one equal too, right? They all have to be a 1/2 inch. So that's equal there. And that's equal there. Now what happens if I put a constraint on that's already there? It tells me that, hey, it's already there. It's okay. That's not an error. That's telling you a message. So the distance here is going to have to be twice the cube distance. So that's going to have to be 1 inch. But what if I just did 0.5 times 2? Could I put an equation in here instead? You bet. So I can actually put an equation into my dimension to make that work. So I can say 0.5 times 2 because I know it's 0.5 for each cube size and I need to make it twice the distance, so 0.5 times 2. And notice that it displays 1 inch. Now this particular dimension that I have here, let's edit that dimension. And that's called dimension 0. That's the name of the dimension, is dimension 0. And there's also the ability for me to change the property so it displays dimension 0 as part of that. That's in one of my other videos. But in this case, I'm going to need to make the top dimension here 3 blocks high. So to make this 3 blocks long, or 3 segments, I'm going to use that multiplier again. So I'm going to dimension this, but instead, it'll over-constrain and accept to create a derivative dimension. Well, if we create a derivative dimension, that just means that the dimension doesn't necessarily is not going to change any of the information on the drawing because it's driven by something else. So I'm going to go ahead and cancel that. But because I made these 3 dimensions equal, I needed to make sure that those are set. The dimensions that are missing, the dimension here to here, I need to make that 0.50, or I could have made it equal to the other one. And this dimension, I can make these 2 lines equal. So I can say I want this line and this line to be equal. And notice that everything now is in purple, and it says that it's fully constrained in the lower right-hand corner. So I can now extrude this, and we'll choose extrude. And do I really want to go in this direction? Probably not. Let's go ahead and change the angle, or change the direction to direction number 2. And the distance, remember that D0 was 0.5? I can say I want to make this equal to D0. So whatever that dimension value is, this one right here, this 0.5, if this one changes from 0.5 to 0.75 or to 1, it will automatically update the thickness to be equal to that particular value. And so I'm using an equation with the variable. So it's just like math class with x and y. Well, D0 is just like an x or a y. So it's just another aspect of using a basic equation. I'm going to go ahead and choose OK. And we're there. Let's go ahead and change the color of my part. Let's see, do we have any really cool looking oranges? Yeah, that's a cool looking orange. And at this point now, my part is done. I'm going to have to save it here in a minute, but right now I'm still in this part, and I want to go back to the assembly. So to get back to the assembly, I have to return out of the part and move up the ladder one level to the assembly. So I'm going to hit return. And you'll notice that all the information now comes back again. Both parts are now fully colored and look good. So this part can be moved around. So I can grab and move that part. That means it's not assembled. So for me to assemble, I need to build a relationship between these two parts, and that's what this relationships area is. I'm going to go ahead and constrain them. We can also create joints, but joints are a little bit more complex than what we need on this particular object. And we need it to be rigid, and a joint typically is a non-rigid position where it's going to move or slide. So we're going to constrain this and make it a rigid location. So we're going to choose constrain, and we pop up our constraint box. Now you'll notice that there's assembly constraints, motion-based constraints, transitional, and constraint sets. We're going to focus right now on assembly-based constraints. And within assembly-based constraints, we've got mating, which basically takes two parts and mates them together. We have angular-based constraints, where two parts will have a set angle between them. If there's objects that are tangential, meaning like a rolling pin against the marble baking plate or against the countertop, that would be tangential. So the roller pin would be tangent to the countertop. Insert is inserting a component into another component, like a bolt or a screw, something like that, or a pin. And then the last one is symmetrical. Well, I'm going to do a mate constraint, and it requires three constraints. Well, why three? Because there's three primary axes, x, y, and z. And then we've got negative x, negative y, and negative z. So there's actually 6 areas of movement, and we also have rotation in there too. But we're going to hold 3 of those. As long as we can hold 3 of those axes stable, the part will be constrained. So the first one that I'm going to do is going to be an assembly constraint, and we're going to go ahead and mate the two parts together. And what that means is that one part in the part number 2, the surfaces will touch. So for example, I can make this surface here touch to the outside surface of the blue block. Now why surfaces? Because the most stable environment are surfaces. The second most stable part, or the second most stable item, is a line or an edge. And the third is a point. And so we try never to use points because they're the least stable. We can use edges, vertices, or points. Not very stable on vertices or points. Now what just popped up there is if I hold my pointer on top of an object that has multiple selections, I'll get a list. And so edges are better than vertexes, but surfaces are way better than edges. So I'm going to pick the surface and say I want this surface, and I'm going to have to rotate this now so I can see the other one. So I rotate it, and I want that surface to be mating with this surface. And so you heard the clink. That's a good clink. And we're going to apply it. What that means is that those two surfaces now meet and are perfectly matched together. Are we done? No. Let me go ahead and cancel this or close this place constraint box, and we'll show you what happened. So at this point now, I can't move my box away from the other box, or excuse me, my part away from the other part, but I can move it in and out in that location. There's also a flush constraint that was created automatically when we extruded the part. So it said that the surface that I originally created when I selected to create the second part, those are flush. Now what if I wanted to delete that? What if I didn't want that to be flush? I wanted this to be connected up above. Well, I can just come over to the browser window, right mouse click, and delete it. And that allows me the control of how the parts are constrained. So you should always try to constrain the part in the way that it gets assembled. So we want this block to slide in. So I do want that flush constraint because I don't want the block to be up or down. And the second constraint I have to have is the inside because I need to make the block stop, right? The block's got to stop on the other part. Now there's one other thing that hasn't happened at this point, which should, because this part can also move. Since it's not constrained to anything, I can right mouse click on part A and I can do what is known as grounding it. And if I ground that part becomes my core or base part and won't move. This part can still move, but notice how now this other part cannot move, the first part. So grounding it puts the little push pin in the part. That means it's not going to move. Can I get rid of it? Sure. I can right mouse click, pull that check mark off, and we're good to go. So I've got my third constraint that has to be made. The first one was automatic with the flush because I created it based on that surface. The second one was mating the side together. And the third one is going to be mating. This one's going to be a little bit trickier. It's going to be mating this inside surface to this outside surface. Those two need to connect. And we can apply it. Cancel the box. Now when I grab it, it doesn't move. That means it's fully constrained, which is really good. Now I just hit the little home up there, so I got it back into an isometric shape. So now we're done constraining part A to part B. We better save it. So saving it means that I'm going to go ahead and choose Save As. It's going to save it as assembly number 1. Let's go ahead and say Puzzle Cube. Assembly, and we'll hit save. Now what's going to pop up is that it's also going to want to save part B. Remember we created that but haven't saved the orange part yet. So yes, I do want to save it. So I'm going to choose OK. So now it's creating part B and the assembly all in one save in that same folder that the original part was located. Alright, now that it's saved, we're going to go ahead and create an exploded assembly, and then we've got a couple of part drawings to do. So to create an exploded assembly, I can come back to the eye and choose New. We're going to go ahead and choose a new presentation. And the presentation is the exploded assembly. So again, I can still have the assembly open in the background. I can create a new presentation and create the view. Well, the view is going to pull up the last Puzzle Cube file, Puzzle Cube assembly, which is what I just saved. And it's going to say that our explosion is going to be a manual. Don't do automatic explosions because you don't know how they are going to react. It's better to work in a manual explosion space than it is an automatic. We'll choose OK, and it brings just what you just saw out of the assembly. But now what we have to do is we have to tweak or move the orange block away from the blue block. And so we're going to use what is known as tweak components. And there's a three-step process. And you can see the 3 red arrows. We have to fulfill all 3 red arrows. The first thing that we have to do is control the direction, then the components, and then if there's a specific trail origin, we can have it edit a specific trail origin. And that just shows you the linkages. If you remember seeing assembly drawings, like for a bicycle or for a piece of furniture, a lot of times they'll have what are known as trails to show you that part A trails over and connects to part B. And that's what you're creating here is the trail. So the first thing is the direction. So you can see I can pick a surface or I can pick an edge. And if I pick an edge, I get the XYZ, which gives me a little bit more control or understanding of what's going to happen. So I'm going to go ahead and make sure that XYZ is popping up here, located, because I'm picking that edge. And now the component that I would like to move, I want to pick somewhere away from the red one. I want to highlight, notice that the edges all turn red. I'm highlighting the edge. There's nothing in the middle that I'm selecting. I'm picking the edge, but I'm picking it far away from the blue object. Now the third thing I need to do is move it. What direction are we going to move it? Well, the first direction we're going to move it is in Z. So I'm going to choose Z. And what am I going to move the distance? Well, let's move it 2.0 inches. Remember, this is 1 inch. So I need to move it at a minimum 1 inch, because then that will align. If I move it another inch, then I'll have an extra one. So 2.0 inches, I can hit the check mark, and you can see that it moved it out. Notice the blue trail that appeared. Now, if I needed a new location for that trail, I can pick a new trail origin. Now, I'm also going to move it vertically in the Y, just to make it unique, and we're going to go ahead and move it 3.0 inches in the Y. And so what's going to happen is I moved it out and up. And so I can control positioning placements of all the objects. And now that I'm done, I'll choose close. And I can do X's, Y's, Z's. I can rotate it, so if the part's not in the proper orientation, we can rotate it. And that's what the second option is for rotation. And I'm going to go ahead and close it. Well, we're at the point here that we can animate it. So we can animate this, and this works just like your DVD player. I used to say VCR, but they don't make VCRs anymore, do they? We're going to go ahead and hit play. Slide it down, and it's going to slide in. And you can see how that works. I can forward it by the tweak. I can reverse by the tweak. So that's one tweak. That's the second tweak. I can also make a recording. Okay, the standard symbol for record. So I can record this animation so I can send it to my friends to say, hey, look at the cool thing that I created. Or I can post it to YouTube, that kind of thing. Now the parameters and intervals. Let me choose reset. The intervals and repetitions. Well, I only want it to do it once. If you want it to repeat 2 or 3 times, you can add that. The interval controls the speed. To go faster, what do I type in? A number higher or a number lower? What do you think? Make your guess. Right. We need to type in a lower number. So to make this go faster, I make my interval smaller, apply it, and hit the... Notice how fast it moves now. And if I do that again by hitting reset, and I go to 5 and apply it, it moves even faster. Well, there's a certain point that you don't want to cross, and usually it's about 10. Movement of 10 intervals is about where you want to be at the fastest. 25 is okay for the single part that we're doing. But if you've got a lot of parts moving at once, and there's other videos on how to make parts move also, because there's a whole section here where we can control and sequence and manage multiple part movements, that requires a little bit more. But right now, 25 is good. We reset. We do that. Perfect. Excellent. I'll hit the reset button. I'm going to go ahead and save it. So I'm going to hit the I, hit save as. We're going to save it as Puzzle Cube Assembly, but it's going to be an IPN. So I can either leave it as that, because even though Puzzle Cube Assembly is saved as an assembly file, it can also be saved under the same name as a presentation. I'll just put motion so that way it's really clear when you're looking at it. And I'll hit the save button. Yep, we made a couple of tweaks to it. We're going to go ahead and choose OK. Our last thing that we're going to do is create a drawing file. And so to do that, again, I'm going to choose under the big letter I. We're going to choose New, and we're going to choose New Drawing. Now, there's a whole setup process with drawings. The basic setup process that we're going to go through is to change the paper size. In one of the other videos, I go through how to edit the title blocks and customize it a little bit more, things like that. You're welcome to view one of those videos. I am going to go ahead and right mouse click in the browser window, and I'm going to edit the sheet. Why? Because I really don't need a C size sheet. I really need a B size sheet, and B size is 11 by 17 or 12 by 18 if you're using the metric sizing, or roughly. So it's 11 by 17. We'll choose OK. Again, we've got an ANSI large title block. Theoretically, I probably should use the ANSI A title block. So to delete it, I'm going to right mouse click and delete. And on the sheet, I'm going to right mouse click, under drawing resources, under title blocks, I'm going to right mouse click under ANSI A and insert it. Again, really simple. Drawing resources has the title blocks and borders. Instead of the large title block, I'm going to use the smaller ANSI A title block. It does bring up the person who draws. That comes from the properties and settings, and we can edit these also. But on this sheet, I'm going to show you how to bring in the presentation file and the assembled file. So we're going to go ahead and use the base view. And right now it's going to bring in the assembly motion, but do I really want a top and a front and a right side of that? No, I really want an isometric view of this so I can see how the part looks and goes together. So I'm going to choose ISO right, locate it on my sheet, and that looks kind of cool. And I'm going to choose OK. But wouldn't it look better if it was colored? You know, that it had the color of the objects on it? Oh yeah, way better. So notice that you get the red box. I can right mouse click and then edit. Let's see here, edit view. That's right here, edit view. So in the edit view, I can change and make this a shaded object. I can also change the scale of the drawing. And again, I've got other videos that we go and change scaling, but right now we're just going to change it to a shaded object and choose OK. Very cool. Now I want to bring in another base view. This one happens to be of the assembly model. Again, I'm going to choose ISO top right, and so this is the assembled assembly. I'm going to go ahead and put this up in the corner here. And I'm not going to project any other images, so I'll choose right mouse click and OK. And again, I'm going to right mouse click, edit the view, and shade this. Beautiful. I need to create a new drawing sheet though, so I can show you how to do a part. So we're going to come over to the browser window, right mouse click, and actually, instead of editing that sheet, I'm just going to right mouse click in the white space below it, and I should be able to create a new sheet. Ooh. It's up here at the top. Boy, I messed that one up. I get one mistake per video, so that's my mistake. Up on the very top row, under the name, is where we select the new sheet. So this is going to become sheet number 2. Notice that sheet 1 went gray. So I just chose this, right mouse clicked, and I created sheet 2. From here I'm going to create the base view, but I'm going to have to go in. So when we chose the folder option to go and look for the file, we then located it in Puzzle Cube Part A, and we'll choose Open. So Puzzle Cube Part A, this one's going to be the front side, but is that the best view? Let's see here, left view, right side, or right view. That looks like the best view right there. That's the most descriptive. Is the scale right? Maybe we should use 2:1, so it makes it a little bit larger scale. Remember, if you change the scale, make sure that you update the scale in the title block. It won't do it automatically. So I've just projected projected left mouse click, projected left mouse click, projected left mouse click, right mouse click, and choose create. And it automatically creates my 3 views with the isometric. Wow. Again, I can right mouse click, edit the view, and change the shader so this one's shaded. Now here I'm going to have to add dimensions, and that's found under Annotate. So we choose Annotate, Dimension. I can pick 2 lines and add a dimension, or I can pick a single line and add a dimension. And in this case, see how I get a bunch of individual lines? I'm going to pick the 2 lines, add the dimension, and then here we'll pick the line, add the dimension. And again, notice how I'm keeping the dimensions out of the part and away from the part. I'm not dimensioning any hidden lines. It's in the best location for part understanding. And there we have it. Editing the title block very quickly. I can right mouse click under sheet number 2. Take it back. We can edit the sheet properties. We can actually use just text under here, which is an easy way to do it. Just pick text, create a window, and then type in puzzle cube part A. And again, the height of the text can be adjusted, so we can make it larger or smaller. Highlight it, then adjust the height. Choose OK. You can put your name in the top box. Don't forget to put the scale, and the scale is 2:1. So we'll put a box of 2:1 for the scale. And that's how you edit your title blocks. Again, go ahead and save it. It's going to be in the puzzle cube. So this is the puzzle cube assembly motion. Well, this is going to be puzzle cube assembly drawing because it is an IDW file. And will it save both sheets? You bet. It saves both sheets and any other of the editing changes that we might have made. So sheet 1 and sheet 2 are saved. If you want to go back to sheet 1, double click here on the sheet. You can go ahead and edit your title block, put your information in, and you're good to go. Have a great day. Hope to see you soon.